coefficient of x in the expansion 2x plus x inverse plus x inverse to the power of 7, right? And you want to find the coefficient of x. Oh, actually, they tell you it's what, 560? 560?
Yep.
They tell you it's 560. So I guess it's the same as finding it, but if you could somehow check it, you could avoid finding it. Which is more of an exam technique. So actually the theorem, the binomial theorem, the reason that they're called binomial coefficients is that when you have 1 plus x to the power of n, right, the coefficient of x to the r is n choose r. Well, n r. That's the same. So if this question was, if this question wasn't 2x plus x inverse, if it wasn't some funny thing like that,
yep.
If it was just like 1 plus x to the 7, right? And the coefficient of x would be 7.
7, choose x.
Choose, it's a 1, see?
Oh, okay. Yeah.
So R would be 1, see? 7, choose 1.
Yeah. Wait, 7 choose 1 is just 7, right?
Yes.
Okay.
Very good. See, it's like when you understand why the numbers like that, then you can always come up with like 7 choose 1 is just 7.
Yeah.
But for some people, that's like magic.
Yeah.
You know? Like 7 choose 1. How does he do that? He's like a calculator. But like if you just know what it means, it's kind of obvious. It's what, 7, right?
Yeah.
And that's kind of what maths is. Once you do it in a way, it's kind of obvious.
Yeah. Definitely.
Yeah. So how do you make this like that? Right? So that's the kind of the problem.
Wait, why do we need to solve what's in the brackets? Isn't it just 7 choose 560?
So the fact that there's different things in the brackets than 1 and x can change stuff up.
Okay.
Like, for example, there's a 2 there. That'll affect stuff a lot because, see, that being a 1 will keep all the, like 1 times anything is 1, like itself.
Yeah.
And 1 times 1 is 1, so it doesn't get out of control. Whereas 2, it might be like 2 to the power of something by the time it gets to that.
Okay.
So in general, actually, the binomial theorem, you can actually phrase it another way when there's 2 numbers that's different. You have x, y plus x to the power of n, right?
Yeah.
And then it's the coefficient. So now it's truly binomial, because this is sort of, there's like a special place for the second nomial. And this is like balance between the two.
Yeah.
The coefficient of sort of x to the n minus r times y to the r is ncr. Or n choose r. So that's the more general version. Okay, and they're equivalent. You can prove that with some algebra, but we don't really necessarily want to do that. Okay, so can you see now that like with this form, actually I might even make it z to make it more suggestive. Z. Obviously it doesn't change anything, right?
Yeah. No, it doesn't.
But it does affect sort of the relationship between this and this. You don't want to think x has already been defined.
Yeah.
So what you can do now is you can let y equal 2x, right?
Yeah.
You can let z equal x inverse. So this is meant to work for any value of the variables.
Okay, so the goal is just to get. Wait. What do we do to get rid of the 2x? Wait, is the x fine being inverse?
Yeah. So let me apply this theorem, and then let's do it sort of more from basic principles, because that might be easier too. So So if I also apply this theorem, right, to the power of 7, yeah, then I'd be looking at the coefficient of, see, for example, the relationship between the terms, they have to add up, the powers have to add up to 7, right? They have to add up to n. See how n minus r plus r is n?
Yeah.
They have to add up to 7. So for example, if I had like 6 for this one, right? I get an x to the power of 6. And then I have 1 for the other one. It'll give me x to the power of 6 minus 1, which is x to the power of 5. It's not going to be what I want, right?
Yeah.
So I need something that adds up to 7, so these powers sort of cancel in some way to get x. So, can you see you can do that with 4 and 3?
Yeah.
So it's like coefficient of 2x to the power of 4, right? Times x inverse to the power of 3.
And then you just calculate that. And
Yeah, because the z is the 2x, right? And the z, so the n minus r is the 4, you know? And then the x inverse is the y, the z.
Yeah.
Oh. Sorry, I have it the other way, but it's the same because it's.
Is x inverse to the power of 3 not x to the power of minus 3?
It is.
Oh, is that what we're trying to get?
Yeah. So, because when you get x to the minus 3, right?
Yeah.
You get x to the 4 here. X to the 4 times x to the minus 3
is x to the minus 7.
No, x to the plus 4 times x to the minus 3. So this is.
Is that not x to the minus 7?
Plus 4,
Yeah.
not minus 4.
Yeah.
Like if x to the 4, right, times x to the minus 3.
Yeah.
It's 4 minus 3.
Oh, I'm multiplying them for some reason. I'm not.
So if it was a minus 4, then it'd be
Yeah.
minus 7. But since it's a plus 4, right?
Yeah.
It gives you x to the 1.
Yeah.
And that's what you want, right? You want the coefficient x to the 1.
Yeah. Okay.
So, yeah, so you got to convince yourself that that's the only combination that you can get x to the 1. There's no other combination. But that's kind of obvious because.
What if you flip them? Does that?
Yeah, so if you flip the numbers
is
around.
It just accepted that that's the same.
You mean if you put 4 here and 3 here?
Yeah.
Then you get x to the 3 times x to the minus 4. Then you get x to the minus 1. Yeah.
True. Good point.
Okay.
Wait, so is that literally just the answer?
Yeah, so you got to apply the thing. So when you count the coefficient of this, right? So by the theorem, is 7 choose 3 or 7 choose 4, right? They're the same.
Yeah.
So 7 choose 3. Okay. So 7 choose 3, you can verify is not 506. Maybe that's something you can try to explain. So the coefficient of this, right? Yeah. Is 7 choose 3.
Oh man.
Yeah, so the coefficient of that is 7 choose 3, right?
Yep.
What's 7 choose 3?
Let's go choose 3.
Oh. We did the calculation, I think.
Yeah, 35, we did that.
Yeah, so that's not the same as the answer, right?
No.
So can you explain why it might not be the same as the answer?
Not sure, to be honest.
Yeah, so the reason is it's the coefficient of this, right?
Yeah.
But this has the 2 here. See?
Yep.
So that has a 2 to the power of 4. So this whole term will be 35 times 2 to the power of 4 times x. See?
Yeah, kind of.
So the point is the coefficient of this. The coefficient is just a number timesing it, right? So it's 7 choose 3 times 2x to the 4 times x to the minus 3, right?
Yeah.
Okay. But then, like, so this simplifies to 7 choose 3 times 2 to the 4 times x.
Yeah. I'm kind of getting it.
Do you know how to expand the power here? Like 2x to the power 4 is 2 to the 4 times x to the 4.
And that's just 2 to the 4.
Yeah, so that's the 2 to the 4 coming from there, and that's the x to the 4
Yeah.
minus the
And then-
3.
Yeah, okay.
So then this is actually the coefficient. See?
And then that's 560.
Hopefully.
Is it?
Well, 16 times 35.
That is 560. I still don't really get. I don't really get it, but